Not sure how long I can make these videos, so I'll just break it up into increments here. This equation here is the conservation of energy, and we're looking at this guy right here is called a control volume. That's what we want to look at. So we want to look at control volume for 1. So if we go back here to our diagram, that's going to be the control volume between 4 and 1, which is the dashed line. So we're looking at the boiler right now. So the change in energy with respect to time is equal to the heat transfer in minus the work being done, which is a shaft work or electrical work, plus the sum of the change in mass times the m dot here, the mass flow rate, times the entropy plus the change in 1/2 the change in velocity squared, plus the change in potential energy here, minus the sum of that going out. So in is coming in here, and out is leaving here. These are being cancelled because we're assuming that the velocity between 4 and 1 is about the same, and the potential energy is about the same. So then that leaves us with, we want to know what the heat transfer in is, which is the Q in up here. These are the same things. So, is equal to the pressure. Let's see. I should explain this down here, I guess. The work here is P m dot v, this is little v here, call it v, out, minus PV in plus the work of the control volume. This is 0. So then we can come back down here and look at the pressure times the mass flow rate times the change in specific volume plus the mass flow rate times the change in entropy. And then here, you look these up in tables of the book here, which I'll show you here can be quite big. All of this in the book is tabled. It's about 100 pages or so of just tables of lots and lots of numbers. This is for a refrigerant, but as you can see there's the entropy, which we want, and also the specific volume. So then this is the table that we're looking up to get these. Here's specific volume, entropy for the state 4, or for the 4th point, and then for the 1st point. Then we can plug it all into our equation, and we know how much energy is going into the system per time.